Hey guys, so welcome back, and today's lesson is going to be kind of a mini lesson on stars. If there's anything in the night sky, kids tend to know quite a bit about. Stars are one of them. So I'm going to be focusing on a few key components today of things that maybe you guys don't quite know, which is the life cycle of stars, how we determine, how we classify them using what's called absolute magnitude, and then how we can tell where they are in their life cycle or how hot they are based on their color. Okay, so those are the three things that I'm going to be talking about today. These are the notebook pages that you guys are going to be doing for this lesson right here. Okay, you'll copy them directly. There's nothing that you guys will have to do until the very end of the video, and I'll give you guys instructions on that in a moment. So what I'm going to be starting with, first of all, is the kind of the textbook definition of what a star is, which a star, of course, is different from a planet is different from a moon is different from a comet is different from an asteroid. So we do have a lot we have to keep straight out there in space. But a star is considered a large celestial body that is composed mostly of gas that gives off light. Okay, so really what a star is a giant chemical reaction. Okay, we know that we can see a chemical reaction if a couple of things take place. So that could be that light is given off. It could be that sound is given off. We might have a charge. There might be a change in color. So all of those indicate chemical reactions. Hopefully you are aware of the fact that our sun is a star. It is just the closest star to us. Okay, so it is the closest star to our planet, and it is also, of course, the center of our solar system. We're going to talk more about the sun when you guys complete the packet that I sent home with you guys prior to spring break. It has a lot about the sun in it, but our sun is considered a medium-sized star, and it is a relatively cool star. I know it's hard for us to look at the sun and think, okay, well, that's just not the hottest thing in the solar system, because to us it feels like it is. But there are many stars that are a lot hotter, which we'll discuss in a few minutes. So, stars also come in several different sizes. As I said, the sun is considered a medium-sized star, but if you compare it to one of the stars that is closest to us, which is the Alpha Centauri, it is dwarfed by it. It is teeny, teeny, tiny in comparison to that star. If you've ever seen any illustrations of it, the sun is like a speck, and Alpha Centauri is huge in comparison to it. So the sun is not considered a large one. Also, our sun, in comparison to other stars in the night sky, stars like Sirius, for example, if you're a Harry Potter fan, then you should know that Sirius Black, a character in the book, he transforms during that series into an animal, and he's an animagus, and his animagus is a dog. The star Sirius is actually is the dog star, and it is found in a constellation that is a dog as well. So that's where she got Sirius's name from, because she was transforming him into a dog. So, but that star, Sirius, if you're looking at absolute magnitude or how bright it appears to us out on Earth, it is far more luminescent. It has a greater luminosity, and so it is considered to be a brighter star than our sun. So, also, objects that glow all glow at a certain temperature. Okay, so we know that here when we're working with things like metals, that if you heat up a metal to a certain temperature, it's going to glow a certain color. And that color can range from kind of like a really cool electric blue all the way to red hot, all right? But it's actually interesting to think that the ones that are red are actually the coolest ones, where when it's burning blue, it is the hottest, if you're talking about stars. So in your notebook pages, there is a chart right here that shows the different temperatures of stars, and it is in kelvins, okay? So it shows that our blue stars are actually incredibly hot. We're talking 2,500 degrees Kelvin or higher. Our bluish white ones are 10 to 25,000 degrees. And then our white are 75 to 10,000 degrees. Our yellow white stars, which is what the sun is 6,000 to 7,500 degrees Kelvin. Our yellow orange are 3,500 to 5,000. And our red stars are below 3,500. So they're actually pretty cool stars. I want to talk to you guys about 3 different terms that are probably fairly new. These terms are how we classify stars in the night sky according to something that is measurable, okay? And I'm pulling this directly from your textbooks, and I'll take pictures of these pages as well, so that if you want to reference them, you can. But the first one that I'm going to be talking about is apparent magnitude. Okay, apparent means, of course, what we can see with our eyes. Okay, if something is apparent to us, we can see it easily. Magnitude is used in lots of different ways, but in this particular case, what it is talking about is the star's brightness. Okay, so the apparent magnitude is the measure of a star's brightness as seen from Earth. Remember, guys, that what we see on Earth as far as stars in the night sky, those stars could be dead. Those stars could be black dwarfs by now, depending on how far that light has had to travel to reach the Earth, which of course is traveling in light years. So sometimes we see the light of a star that has already burned all the way through those gases that cause it to glow, and it has now burned out, which is really interesting. Using only their eyes, ancient astronomers described star brightness by magnitude, calling them first magnitude, which is interesting. Today, the brightest stars have a magnitude of -2, and the faintest stars have a magnitude of +30. So in the case of the sun's apparent magnitude is -26.8. So that shows you that that star is not actually considered to be very bright. However, Sirius, which I just talked to you guys about in our night sky, has a magnitude of -1.46, meaning it is a very, very bright star, with Betelgeuse at a +45. Okay, so that goes to show you how different those are in brightness, which can also be correlated to their size. The second term I'm going to talk to you guys about is luminosity. And luminosity is the actual brightness of that star. Okay, so we are taking out what it looks like from Earth, and we're looking at actual brightness using a scale called absolute magnitude. Okay, not apparent magnitude, but absolute magnitude. Absolute magnitude is how bright that star would be if it were measured at a standard distance. This is what that means. That means that if we were to put them all in the same exact place, not different distances from our planet, if we were to put them all in the same exact spot, how bright would that star be from Earth? So we are taking that distance portion out of it, and we are placing them in exactly the same spot and the exact same distance away from us, and then looking at how bright they would be from the Earth. And like I said, that is considered absolute magnitude. Now, let's talk about the life cycle of a star, because it can go one of 2 ways, all right? This is the page for the life cycle of a star, and you will see that all stars start right here as a stellar nebula, okay? That means baby star, okay? That's what it means. It's a little baby star. And these are really cool. We can see them really well through the Hubble telescope. They look simply magical. And what that is it's where, because of the law of universal gravitation, that things are going to pull into a center of mass. They're going to pull in, and all of these gases are going to start to pull in really, really close. And they're going to pull in closer, and they're going to pull in closer, and they're going to pull in closer until they are close enough that those chemical reactions can take place. Those gases can start to react with one another, and we have a bright, shining star. So what they will begin to do, there are two courses of action here. A star is going to either go one of two ways. It's either going to take this track or it's going to take this track, okay? So you'll see they'll both start here, about the same size as the sun, and then you have a stable stage of a star. That means it's going to start to emit light. Over here, this is, guys, the life cycle of a star is very, very, very long, okay? This is not, it goes from here to here in 100 years. We're talking thousands and millions and sometimes billions of years worth of life cycle. Over here, it's going to begin to expand. It's going to get bigger, and it's going to actually cool off, because remember I said over here that a yellow star is hotter than a red one. So this is it hotter than it is over here. It's going to expand and cool, and it's going to turn red. A red star is a dying star. Okay, that means it's starting to kind of run out of fuel a little bit. What it can do then is become a planetary nebula. So that means it's going to let go of all of its outer layers of gases, and it's going to look different structurally. And it's going to have a very, very hot core at its center, but everything else that was around it has kind of dissipated. It's left the building. Then this core of the previous nebula, remember a nebula is like a little baby, can become what's called a white dwarf. White dwarfs are going to be when it kind of pulls back into its center and all that's really left is the center. And finally it can collapse, completely burn out, has no more gas to burn, and it will become a black dwarf. Okay? That's one way it could go. Down here, typically these are larger stars, okay? Bigger than the sun stars tend to go this way, which your stellar nebula is going to turn into a massive star. We're talking one of those big boys, okay? It's going to become a red supergiant. Again, blue is hotter than red if you're talking about the temperature of a star, but it's going to begin to expand. Like gases do, they're going to get much, much bigger, and then they will go ahead and they will begin to burn a bright, bright red. What that can cause later, we're talking well down the road, okay, a long way away, eons away, is it may form a supernova. When stars go supernova, they basically explode out, and that blast, it blasts away all the outer layers, and so all it's going to really leave is that core portion. Now what can happen here with your larger stars is that once the supernova burns out, it can collapse kind of in on itself, and it can become a black hole. Now, as you guys know, because we talked about it earlier this year, this shape of a black hole was just theorized mathematically until we got some photographic proof using a composite photo about this time last year. And that photo shows the light of a star being sucked into the vacuum of a black hole. And it looks like just a black circle in the middle of space. So what that means is that this still is going to take up space, and it becomes this giant vacuum in the night sky that will kind of spaghettify anything that comes close to it, and that includes the light of another star. Okay? So this is kind of a simplified version of it, but it does show all the different colors that are in this chart right here. Okay? And then lastly, what I thought I would share with you guys is a couple of different ways for you to look at the night sky using some technology that you guys may have at home. Nothing that you have to build. And one of those ways is with the Google app, which is Google Sky. And it's a fantastic app for your phones if you enjoy kind of looking past your day and seeing what is out in the night sky. I took a screenshot of what the night sky would be if it weren't the middle of the day. And in my sky map, I can see the sun, I can see a planet, I can see the Pisces constellation, which of course, if the day were not so bright, I could see in the sky as well. So I'll try and insert that into here. But it's a really fun one if you want to look for your constellation for your birth month, or you want to look at the relative size of the stars. It does show it, excuse me, it does show it in Google Sky. okay? And then lastly, I wanted to show you guys or talk to you about how you can find Canis Major, which is the constellation that has the star Sirius in it. All right. So the big dog, which is the name of the constellation, or Canis Major. Canis, of course, means canine. Major is large. Looks like he's barking at the constellation Orion, which is my favorite constellation, which sounds just about right. Early astronomers imagined him as Orion's companion. In the neck of the big dog is a star called Sirius, Latin for the dog star. Sirius is a binary or double star, which is part of the reason why it's so bright, and is the brightest star in the entire night sky. If you see something brighter, it is most likely a planet. So I'm going to show you guys this illustration up close so that you guys can try and go out tonight and see if you can find Orion is easiest to find because you can look for his belt. And then Betelgeuse is also in the Orion constellation if you were unaware of that, which is a large star in the night sky. And then right next to him is Canis Major, with the brightest star in the sky being Sirius. So I'm going to show you guys this. Sorry that it's a little bit fuzzy, but Sirius is right there. So here is Orion, Betelgeuse, and then there is Sirius. Okay, so that is our lesson on the life cycle of stars, how we classify them with apparent magnitude, absolute magnitude, and looking at luminosity. What I want you to take away from this is that stars are in different stages in their life cycle. We can determine what those are based on their colors, and that we can also determine how hot they are. Sometimes we can even tell composition from how brightly they're glowing, and some of the brightest stars in the night sky. Okay, I'll see you guys soon. Bye-bye.